Hi everyone, so I want to do a quick little video about LD50 and toxicity so you can do a free response on this. In order to talk about toxicity and LD50, we first have to define what dose is. Right? So dose, if you're talking about dose of some kind of chemical, right? Dose is the level of exposure. So this could be radiation or UV as well. Level of exposure times the length of time that the exposure occurs. So level of exposure could be something like the concentration or the amount of a drug, length of time the exposure occurs. So this could be, how many times you're given that drug or that chemical, or maybe if you're talking about UV radiation, like how long you're exposed to that UV radiation. When you do a dose response study, you expose animals or plants to different amounts of a chemical or radiation or some kind of exposure, and then you look for a variety of possible responses that could include mortality or even just changes in behavior or reproduction. When you're looking at the effects of different exposures, you can look at it in a few different ways. One way of looking at it is by examining the LDL0. Right? So LDL0 is the lowest dosage at which death occurs. Right. So the lowest dosage at which death can occur. So the lowest amount of a chemical or the lowest concentration where you experience some kind of death. You can also test for something called LD50. So this is the lethal dose, so killing dose, that kills 50% of the organisms. And this is used to compare harmful effects of different chemicals. So you can use this as sort of a comparison. You're not always necessarily trying to look at how chemicals kill things, right? Like sometimes there are other effects that can be harmful, but don't necessarily kill an organism. So you also might want to examine the LD50. So this is where death is not always the objective, but you can have a chemical that doesn't kill necessarily, but can impair behavior, physiology, or reproduction. Right? So this is the effective dose that causes 50% of individuals to display a harmful but non-lethal effect. When you're testing for LD50, LDL0, or ED50, when you're testing for dosage and harm, right, you can do an acute study, which is where you expose individuals to this hazard for a really short duration, and then you can also do chronic studies where there's a much longer period of time of exposure. At the end of a dose response study, you count how many have died after exposure to concentration, and generally this pattern is going to follow an S-shaped curve. This S-shaped curve is going to look something like this, where on the x-axis you have the dose of the drug or chemical or exposure, right? It doesn't necessarily have to be a drug. And then on the y-axis you have the effect, right? And the effect could be something like change of behavior or reproductive harm, or it could be a lethal effect where you'd be looking at the LD50. So at lower dosages, right, you're going to have lower amount of harm, and then at some point this effect is going to increase sharply with the dosage of the drug, and then at some point you're just going to kind of level off where the effect is really high at really high dosages. If this was something where you were looking for the LD50 or ED50, right, if this was 100% of the organisms, right, and here is 50% of the organisms, and here is 0%, right, if you were trying to find the LD or ED50, you would look at, okay, where is there a 50% effect, right? You'd go over to the line and then you would drop down, right? And then this dosage would be the ED50 or LD50, right? The dosage where 50% is killed or 50% has some kind of harmful effect. So if you're trying to compare two different dosages or two different chemicals, right? And here's your effect and here's your dose, right? Let's say one curve ends up looking like this, right? And then another curve ends up looking like this, right? If you then go, okay, here's 100%, here's 50%, right? And you go over and down, right? And you go over and down, right? You can see that this one has this dosage for LD50, this one has this dosage for LD50. So therefore, the red chemical is more harmful and more lethal, right? Because a lower dosage led to a 50% mortality rate, right? So lower dosage leading to the LD50 would make that chemical more harmful, and then the blue would be less harmful. In addition to dose and dose response, you can also talk about threshold level. So threshold level is the level below which no ill effects are observed. When you get above the threshold level, the effect of the substance is going to depend on both the concentration and the duration of the exposure. So what you end up with is you actually end up with a graph that looks like this. So here's the time of exposure, so how long the exposure has been. And this is concentration of the chemical. So again, you don't necessarily have to have chemical. This could be like UV radiation or X-ray radiation, right? And you end up with a curve like this, where down here, right, green, so you get no harmful effects, right? No harmful effects. So that black line is your threshold level, right? And above it, now you have the harmful effects. This is just to show you that you can actually tolerate higher levels of concentration if the exposure time is short, right? So the dose is actually remember, dose includes the amount of exposure times the amount of time the exposure has occurred, right? So the dose is actually more important than the absolute amount, right? You have to consider both the concentration of the chemical and the time of exposure. You can also have really low doses, but then if you are exposed to them for a long period of time, then they can be harmful. All right, so that is it for now on toxicity.